Okay. I hit start stream before I even had my mic plugged in. Hope you guys can hear me. How you all doing? My bad. All right. Let me know if the mic's actually working here. Hopefully it is. Okay, cool. Yeah, sometimes I do that. I get so eager to start the stream, I haven't even plugged in the mic. Okay. So today we are doing a kind of impromptu stream. I'm not streaming on Friday, and I wanted to talk about some of this stuff because it's been coming up in conversations, and I've been slowly making progress the last few weeks. This is why I haven't done a stream. I've got like 8 hack MDs since the last stream, where I've been working through design thought issues. Not all of them are related to concurrency and transitions, but I thought maybe take some time today to talk about the ones that are and kind of go and look at this topic again with refreshed eyes now that I have, the original context that I built this under. Actually, I guess the original context is one I saw from React. The context that I built this under originally was Solid 1.0 or before 1.0. I think the first version, I was just looking at this the other day. Let me see here. Sorry, let me share my screen. The first version of Solid that had transitions was version 0.15.0 that came out on December 16th, 2019. Been looking at this for a long time. And then obviously we did updates around the time of the 1.0 release. And then I haven't touched it since 1.2, I think, like very early on. And I've been redesigning it again for 2.0. But I mean, I shouldn't say I haven't touched it. We hit some interesting new use cases as we went into router actions and queries, like that whole area. So there's been a lot of thought, but not a lot of update on the core mechanism. So 2.0, I get to start over again. But I think before we even get into all of that context, we should really start with like, what is a transition? Why is it called a transition? All that kind of stuff. Might be a refresher for some of you, but I'm also banking on a lot of people haven't actually used these features in React, don't really understand why they exist. There's a lot of confusion. I mean, it's funny, people talk about confusion around RSCs, like React Server Components. Before that, there was confusion about the concurrent model, and it's a really powerful thing. And what it automates, it removes a whole bunch of concerns that you'd otherwise have to deal with. But you have to also kind of respect the model, otherwise you'll be fighting against it the whole time. So I think we probably should start there. All right. Anyways, yes. Hello, everyone. As I said, I decided to do this stream today, mostly for my sake, because I just needed to kind of like talk through and like get some sanity around this stuff. You work on something too long, in a specific space, and then you're just like, you almost like develop your own micro language or your own like world, and it's kind of isolated from the real world. Yeah, sorry, Fuzzy. Yeah. So first of all, why transition? I honestly don't know why React initially went with that title. I have no insight into that. I picked it up originally because it was their call, like what they called it. So I was like trying to imitate, this concept. I didn't know what else to call it. It's unique. And I started going over different names, different titles, especially when I came into Solid 2.0, but then I kind of just went back to transition. See, the problem with transition is it conflicts with like view transitions or transition group or like animation type stuff. And while this feature can be related, it isn't that. Yeah, we're going to be doing some Excalibur today, most definitely, I think. Let me open that up because because transitions are, for people who are not familiar with them, most similar to transactions, right? Most things that you do in reactive frameworks, and I don't just mean with signals, I mean with React, with whatever, you set some piece of state, and the guarantee is that everywhere, by the time you look at that state, has reflected that change. So like, you want to make sure it's consistent. You don't want someone to see, let's say you have two different data points that change or whatever. You don't want to see data A in its original state and B in its updated state. That would be called tearing, where you have like intermediate states, because there can be side effects, impacts of this, while it stabilizes, while it like kind of settles down. Like if you had to hit an endpoint or an API call based on two different pieces of state, and one updates and tells it to update, and then the other one updates and tells it to update. Well, you did two fetches when you could have just done one, right? Like if both changes are happening at the same time, you shouldn't ever create these diamonds or these fetching problems. And we've talked about that a ton on stream. But the challenge is these guarantees can only really be made synchronously. Like when like once something goes async, you no longer can know, because it's not like you're going to have that first fetch wait indefinitely. It doesn't know that it needs to wait. So for that reason, we enter a zone where there's like what I call the three different modes of what you can do when you hit async in general. And what I talk about this is with signals, we talk about this, but it's funny, React's use hook has similar semantics in that it's read based rather than write based. And what I mean by that is it isn't the fact that you're fetching data that causes your component, like it is why your component suspends or it throws or whatever, but it's not the point at which you do the fetching that matters. It's the point at which you consume it that matters, because that's the point where you can't render the UI. That's the point where you can't show the piece that you need to show. If something errors with your async data, yes, you can handle it where you do the fetching, and you could if you doing retry logic. But if you fetch something and no one is listening for it or using it, then the UI can render perfectly fine. So that is kind of the kind of mentality that we've been looking at a lot with async, which is actually turning it into a graph, essentially a dependency graph, just like in typical reactivity. So let me take a look here, and it's funny because I probably made this list before on stream, but we'll do it again. When you have async, there's three things you can do when you hit something that can't render, right? You can pair, which is usually the default in most systems. What I mean by that is pretend you have a user ID, and whenever it changes, you fetch a user. You can show and the first thing you do when you want to fetch the next user, you're going to the next tab, you're cycling through the users in a modal or photos or whatever, is show the updated ID, because you need to update the ID to go fetch the user, but you're still going to be looking at the old user for a moment. So this is called tearing. So this is updated sync state, stale async state. Okay. Can you all see this? Maybe I should make this a little bit bigger. Let me change my text size here. This should be extra large. Yeah, whatever. I'll make the whole thing extra large. I don't really care. Let's move this farther up. Okay. Next. So we've all seen this. From a framework standpoint, this is generally undesirable, but there are cases where this is, acceptable You know, like what if you're doing like a autocomplete search on the page? Like you're okay if you can like type ahead and like do stuff and have things working in the background. You don't need it all to stay perfectly in sync. The input field does not need to reflect the results that you currently see on the page. You're allowed to type extra characters and be searching and stuff. So tearing is fine for a lot of stuff, and it's what we're accustomed to, because one of the cool things that tearing has that I'm going to add a little sub note here is affordances or staleness are sort of built in. What I mean by that is, I said sort of, but they're built in, because when you see the updated sync state, like it's it's not that the affordances are built in. Sure, that's not quite the right wording. It's more that like immediate feedback is the best way to put it. There's immediate feedback because the second you click the tab or change the ID, you'll see the updated ID or see the updated tab. So the user knows that the button click worked. The problem is you're showing them like some kind of half and half state, which again, for the UI, lowers confidence. And I mean, for background processes can be detrimental, right? But there's immediate feedback. Person doesn't think your app's hung. The second state of the universe is what we see a lot with suspense, which I call is bailout, which is basically show nothing or something else, right? The idea here is like stuff like suspense is an example of this, await components in Svelte or whatever. Like, I mean, at least classically, I know they have a new async model. We could probably talk a little bit about that as it comes up. But my point is, yeah, I'll talk a little bit about DaVinci a bit later and the updates on Start. Yeah, so what I'm talking about here is like show a fallback. But it's important to understand that what's beautiful about this is it's actually we can add some more notes here while we're in here, right? Because this one has immediate feedback, but inconsistent. This one also has immediate feedback because, and it is consistent because it doesn't show anything. So like the second something goes loading, you suddenly see a fallback, right? But I will say, incredibly jarring when you already have data, right? So what I mean by that, I mean, I think everyone's seen this. I'm just gonna do solid.com. I'm sorry for people who already know all this stuff to start with the basics. I just want people to understand the language that I'm using when I talk about this stuff. But if I go into the transition example, but don't do it with transitions. Every time I switch, you see some kind of loading indicator, right? This is fine, but picture if you're on a page and you're doing like a type ahead. As I said, there's different types of scenarios you can think about. It'd be very brutal if the whole thing just kept on, like every time you typed a character, it would like unmounted and then showed loading. And this is really easy to do with suspense. This is the kind of thing that makes people go kind of nuts with it. Right. Which I'll get to in a minute. So sorry, where's my Scala draw? Yeah. So challenge drawing when you already have the data. Yeah. So yeah, and you get these like intermediate states. Suspense is good at bundling them together. So instead of having like 20 spinners, you have one. You know what I mean? But this is don't get me wrong. All these patterns are they're not bad. They fit different kinds of use cases, right? Okay, let's go down to number 3, which was just suggested in chat, which is hold in the past. show the current until the new is ready. This one, the challenge here with this one is because you're like, okay, well, this should be the default, but check it out. You said to yourself, I'd rather if something loads fast enough, not to bother showing empty state, just keep loading. If it loads fast enough is the key, because this, no immediate feedback automatically. Like these ones are automatic because the thing just unmounts. This thing, the sync state will update, so you'll see it. But this one has no immediate feedback, which makes it very awkward to have as like a default, because if something is not fast, then, well, you have no affordances. People think your app hangs. And this is something that we've hit in Solid Router, right? Because if people don't use is routing signal, like the thing to say that, hey, I'm pending, then they don't get any affordance, right? Like I'll go back in this transition example and I'll solve it. And see, in this example, I've added like this nice little fade out with a delay on the CSS. So if it happens fast enough like that, you don't even see a change. But if it takes longer, I mean, I could probably adjust this example to take, is there a way I can make the promise take longer? Yeah, let's make it like 1,000, yeah. See that, like how it grays out? But now picture if I didn't add this, what is it called? Where is it? Classless selected, tab, where is it? Pending. Yeah, if I didn't use the pending, see in here we have use transition pending. If I didn't put this pending state in here and I just said pending false all the time, what's going to happen is when I switch, I'm going to click and be like, what's happening? The router is really, really slow. I click on it, you know, and there's this delay. Click. Okay, that one was fast, but click. And suddenly you write an issue on GitHub that Solid Router is really slow. It's waiting for the data, but you have no affordance. There's no immediate feedback here. I think this is, yeah, sorry. This is the one that actually makes it longer. I made the other one variable. Should have been like this. Yeah, there we go. Now it will, you're like sitting there waiting for the page to load, and then, right? Right. I mean, my preference is the old state, but make it obvious the old state is shown. And if it loads fast enough, if it's still slow enough for me to see the loading state for a bit, keep pretending it's loading for just a bit more. Yeah. I think the thing is, people, this is a great comment because you're actually asking for the page to load longer here. But the irony is, and this is why, you know, one of the reasons that I was really into transitions, because this is what we're showing here is transition behavior, holding the past. And I'll explain why I use transitions in a minute. But is most people, and then when you add, I mean, let's go back to our original example with the transitions. I remember I took this into my office workplace and I first showed them this, right? Or sorry, no, let's reset it. I first showed them this. I showed them this experience. Right? And then I showed them this experience. And most people told me that they thought the second experience here was faster. Right? Like I could be a little less aggressive on the fade out delay on this timeout. Like if I delay it, let's say 0.2. Yeah, exactly. There, I delayed it long enough that, like, I did this one shorter so you could be more visual, but most people said this looked faster. They thought it was faster. Right? So, like, you can, in theory, even make it take longer to load as long as you do it in a certain way. People will feel that the loading is faster. I'm not suggesting necessarily make your page loader, but in general, delaying the pending state on transitions is kind of is often a good thing, just a little bit, because people have a certain threshold, I think between 200 and 400 milliseconds, where they're like, okay for it taking a while. So if you don't show the loading state during that time period, you're actually okay. Yeah, right. Exactly. So there are proven UX reasons why people want this sort of behavior, right? Um, and this is why this is hard to do, or why this transition we'll talk about in a minute. But there is actually a fourth option we don't talk about very often, which is, you know, a pretty powerful option: predict the future. Um, so if you know what the good old reason why people add mirrors to elevators, interesting. Yeah. So what do I mean by predict the future? Um, well, if you know what's going to happen, you can kind of fake it. So this is stuff like temporarily add next state. This is things like optimistic updates. What's nice about this is immediate feedback, consistent. Can't always do this because you don't know what the impact is of what you're going to do. Do you know what I mean? Like, sure, like if you're doing a mutation, you know what data you're saving. You could pretend that data is already in this data set. But if you're just like saying, I need to refresh the data on my page or get the next user, you don't know what that user looks like always. I think from a pure UI standpoint, an example of this is when people like stub out, but like there's a lot of similarities. Like when does this become this bailout, right? Because if you could just make more realistic looking uh placeholders essentially, right? Because in a sense, predict the future is putting in a placeholder. So arguably, maybe this is like not an actual. It's like just a version of two. Because look at the characteristics: immediate feedback, consistent. Instead of being incredibly jarring, this one can't always do this. Do you see what I'm saying? Like they're basically the opposites of each other. Like they basically, if you bail out, it's jarring. If you can predict the future, it's less jarring, right? But they actually have the exact same characteristics between 4 and 2. Um, so I don't know if 4 is actually, if we should just categorize it under 2. But for me, when dealing with async, there are really these 4 options, pretty much. Okay. So everyone chat still with me, right? One is easy to do. Um, right. If the funny thing is, it's like even easier to do with something like signals than like top-down VDOM render, because literally you can just be like render something and do like a conditional, and then when the signal triggers, it doesn't rerun the components. It just like literally goes from where the like the control flow is and continues on. But you can still do this in React or any framework. It's very easy because it's once you have like an ID or something in place, like I think we've all written probably, I mean, I go on the playground right now, but we've all written this code before, right? Where you have something that's like, I mean, I'm going to use solid as an example, but you have something where it's like show when uh, data, or let's say user. Everyone's seen this, right? Show when user. For you all who aren't familiar with solid, I think you can still figure out what this component does. And then like inside, you can be something along the lines of like, I don't know, you're showing something with the user information, right? You're like div. Don't get me on my CSS here, but you're like div user dot name or something, right? once this is true, and like then this is always going to be true. Like even if you have like some lovely code up here that's like const id set id. I mean, it could be from a props, but I'm just doing this for fun here. We can just go like id equals 1 and then be like, I mean, let's do this the old fashioned way. Create effect. I don't even need to use create effect. Actually, it's solid. Oh, actually, I do because I want to react to the thing. Okay, so if we did something like this, where we're like, so I could use an async function and add cancellation. Let ignore race conditions and cancellation for a second. But like if we did something like fetch user ID, then set ID, or actually, sorry, then user set user, right? This is like the most kind of dumb way of doing async. What my point is, you can see this directly from this code, hopefully, is initially user is undefined. So when it goes show user, it's false. And then, which means it doesn't do this. And then, but it runs the effect on the ID, fetches it, and then once it sets the user, it continues from here and then does a username. But when you set the next ID, when you increment it to ID 2, what ends up happening is show user is still true because you have user 1 already here. So then it fetches, and then it shows. But if we had somewhere also in the UI something like this, where we're like div. Now, if you're smart here, you know, you would just go user, you just use user.id and people would know that it's the same user and like it would update with it. But you don't always get to do that. Like, let's say it's tied to something, a different component somewhere else, you know, being used. If you used ID here, what you would see, I mean, we could just do this right now just for the sake of showing off this demo. I mean, let's just implement our function. Function fetch user ID, return new promise, resolve, set timeout, res. Then we'll have to make something up, which is like ID name, whatever. I don't really care. And give it a 1 second timeout. Import create effect as well. Create effect. ID is a number, hopefully. On let's import. Is it show? Okay, and then all we need to do here is add a button. I'll put the button in here too. It doesn't have to be, obviously. In other situations, the button would be problematic if it was in here. But for the, let's increment it, and then on click. Set ID +1. Okay, right. The caring, right? ID updates. I mean, I can make this more clear. Right. This is kind of like the default. You know what I mean? All right. Yeah, so you can click it like 5 times, and then this is because these are set times. But if we wanted to make real chaos, I would make this last number random, and then you would see all sorts of problems in race conditions here. So, I mean, right off the bat, I mean, we see problems with the naive solution, but there's ways to fix this naive solution. One of the ways is using dedicated data fetching primitives, stuff like React Query, stuff like solids resources or create async. These will deal with the weird race conditions, right? So that, but in general, there are cases where this is not desirable, is all I'm trying to get at, right? Let's go back here, right? Immediate feedback though, right? I click this thing. The second I click it, that updates. I know something's happened. So that's easy to do. This is also easy to do, the bailout, right? I mean, forget about nesting and suspense and all the cool stuff. All you have to do is essentially add some kind of loading state conception, because if we add another signal here and go const is loading, set loading, right? And we can say initially loading is false. It doesn't really matter. It's going to load right away anyways. So then we go here, set loading, true. And again, we're not handling race conditions. We're not handling all the other fun stuff that comes from this. I know I'm glazing over this stuff, but that part is actually handled pretty well by most frameworks these days, as long as you're not using useEffect, as long as you're using, I guess React doesn't ship with it exactly. I mean, they have server components that handle this, but like it's so, I haven't used useEffect the data fetch forever, because we introduced basically something like a very basic version of query in Solid back in 2019, 18, like right at the beginning. I was just like, this is so many places to screw up. But all we have to do here is we wrap the loading state, and then you go when not is loading, and there's a user, then we'll show this. And then obviously now we can't, we need a fallback so that we can actually see that it's loading, so that when we click it, there we go, loading. I mean, this isn't suspense. This is way simpler than suspense, but you get the idea, right? And this is where I was talking about where the button might actually be on the inside, might get on it. Let's do a fragment here. Okay. Now what we can do is we can keep the button here. My CSS is just terrible. I'm like, just to be lazy, I'm just going to do this just so I don't have to deal with just changing the inline. Yeah, there we go. Solved. Okay. So my point is, I can hit it like 5 times. Oh, look, this actually screwed up because of this doesn't handle race conditions. It's not keeping a counter. This is why I wanted to show again just how many places naive data fetching falls apart, because if you have multiple concurrent ones, this loading can't be true. It actually has to be a counter. So then you have to, like, change this to 0, and then change this to C -1. And even this won't handle stuff coming out of order. This will just make this this particularly perfectly symmetrical time example probably work when I click it like 5 times. Yeah. But it's kind of crazy that when you use frameworks, you have to manage this stuff. As I said, I'm not even using random return times, right? Because otherwise that would throw a freaking wrench in everything. But Well, the reason I want to show it this way instead of using suspense or like transitions and type stuff is that these are general concepts. This is like physics. This is like truth of the universe of how you can handle these situations. There's not like, this is not framework specific. This is just reality, right? Suspense is an example of this, but you can do it manually, like I just showed. Suspense is powerful because it does a, what do you call it? Like the thing, I can't forget, I forget the programming term for it when you inversion of control. Yeah, inversion of control. Suspense basically lets the children decide the situation. Okay. So let's continue. Let's talk about hold in the past. Reason hold in the past is so hard is this situation. Now, I'm going to get rid of the loading for a second because now we're back to like not doing the loading, right? I mean, we might still need to know about loading, but it's not going to be dictating whether we show stuff. So I'm going to leave the loading for now and see if we need it for something like in a minute. But if we wanted to hold in the past, our problem here. Now, obviously, I could use user.id, but that's not a fair testimony of holding in the past, right? The way you hold in the past, yeah, I probably don't need loading for this example. The way you hold in the past in the naive way would be to go const next ID set next ID equals create signal, and we'll start at 1 here as well. Okay. And then the problem is you need to update the thing here in order to fetch the data, but then you don't want it to update here. So what you have to do is essentially, just conceptually, if you make it next ID here, and then when you click, you set next ID, and then when you finish the fetch, you go set ID to, ID. Or actually, a better way to do this would be, more correct way would be const ID equals next ID. So you want to grab the one that you fetched with. You don't want to like read it at that point and then set it like this, right? There we go. There we go. And if I click it 5 times, that's fine because it makes sense. We're not, but you understand that this actually has the race condition problem. When you see stuff like that, you know that potentially if these took variable different timings. So if you could solve the race condition problem, like with your base primitives, like don't use create effective data fetch, use, a data fetching primitive, then this would, basically when you click it 5 times, it would recognize that and then it would jump from 10 to 14, right? But my point is, this is how you do it. And it's not hard to do. What we did is we took the state and then we forked it. We created a different version of that state and said, look, we're going to use that different version to fetch. So we're going to set it ahead, and then we're going to do our thing, and then we're going to update the synchronous graph at the end so everything is consistent at the end, and kind of like shift it through. Now, if other things derived from ID or next ID, then you need to pull them out and fork them as well, because basically every part of the chain that happens before the data fetching needs to not apply until the data fetching is done. Right? This is very important because this is like an on write consideration. It's not on read. We were talking about on read because we were worrying about like, can we show the UI? But what this means is up until the point of async, right? Every data propagation can't be committed until the async is done if you want to have this consistency. Otherwise, something's going to leak. Something else that depends on it's going to show up in the UI or show up somewhere else. So it's not as simple. I mean, it's fine if you control everything. Let's say you own the router, right? Conceptually, if this ID is your location, and then this is your next location, you know everything that you need for the next location, the data fetching, all that stuff. You control that all within inside your system. You could build a whole system out that reads off next ID based on your internals, and then at the end expose to the user maybe this ID stuff. Well, I mean, it's a little trickier that, right? What if the user has to use your location somewhere deep in their component tree? They need the updated location when it's rendering the next page, but then you at some point you're going to switch it back on them. Like, do you re-render the page again? Like from React standpoint, or like how do I swap it from listening to next ID to normal ID, like from a reactive standpoint? Like, let's say I build the next page all using next ID, right? And then at some point it has to become the ID so that when the next page comes, it doesn't immediately change because it's the next ID. Like, this is very easy to understand from a reactive graph standpoint, because you literally made the dependencies against this signal, not this signal, which means that the following one, it's still going against this signal. You want to almost swap the signals to go back from next ID to the generic ID so that the next page can render off screen and you can keep this one fine where it is. But let's pretend we're not using signals. Let's pretend we're using React. Well, if we're using React, it's almost like we have to render the page again, because there's this like kind of weird awkwardness here. Split context, so the fork has the next location, that's the URL bar, and the previous view has the later location. Yes, but then at the end, you have to reconcile that so that the next becomes the current, so that then it doesn't get changed when the next happens. And you'll still want it loading affordance. This was the problem here, right? No immediate feedback automatically, right? So you're right. I took out the loading affordance, but realistically, you're right. Sorry, let's add it back in. Is loading, set loading, because yeah, it actually didn't remove the need for the loading affordance, really, because now what we actually want to do is we want to do it in a different way. We have to go set loading true. Doesn't really matter. Set loading false. And then we don't want it to yank it out because that defeats the whole point of keeping the pass. But we might do something like, so we don't have this fallback loading, but we might do something like, whatever. I'll just do a div, you know me, div soup. Something like is loading actually I can just do this, I think. All right. It's because there's no initial. You see, there's actually two different loading states. I got rid of it. If I put the fallback here, fallback loading, it's a different loading. This is like the initial loading thing, and then this is like this race conditions again, but you get the idea, right? Because this way you can hold in the pass while giving the indicator. This is the like graying it out thing, where the fallback is like the suspense, right? So we're actually talking about multiple affordances. This is why. This is one of the reasons why you can't just default to number 2, right? Very easily. Like, where does this come from? Like, some people, or sorry, I say people, but some frameworks kind of been working on approaches where they can do something, default to number 3 here. Some frameworks have been working about injecting this kind of loading state through like components, so that like it kind of holds and then doing that. But the problem is, and you can see this here, is conceptually, you could do this at a component level, but it's very, very restrictive, right? Because transitions are actually global, right? They're above the suspense. It's everything before the async that matters that you have to fork. So the second you make the transition about the components and try and localize it, you can immediately break that by making a change higher up. So like, it's not the right mechanism for holding to just say like, oh, I hold at component level. It actually doesn't make sense, because this is on a write. It's where the write matters. Components are about the read. So like, this is a hard problem. There's I'm hoping you're starting to understand why frameworks have built-in async primitives. I mean, React doesn't really, but I mean, use is verging on it. And I mean, it's why they push server components, because it handles this stuff. Because like, streaming in this can also be handled if you have the primitives, and you can actually inform stuff like SSR and stuff. But it's also why transitions are not simple to bypass. Sorry, the same context key, but the fork has this next value. So when it swaps in, there's nothing to update. So like, yeah, I see what you're saying. Like, you keep the signal references the same, but then like you just keep on creating the next thing, and like you swap the pointer to what is next, essentially. So you build the next tree with the graph, and then the code that like will build the next tree will create new signals, and they become the next tree, and so on. So you switch the pointer basically to the section of the graph, so it doesn't have to actually update. It stays fixed on the same thing. Yeah. That being said, that only really works, as I was saying, is in a situation where you can control the fork state. So like, if you control the router, and you can be like, look, the router has this capability specifically. It's not a generic mechanism. You know what I mean? Like, you can be like, I know everything that is going to derive off it, and I'm the one who's actually supplying that to my downstream, to like my downstream things, right? In that scenario, you can build a very like, you can contain the solution specifically. Yep. I mean, yeah. Actually, I like this. You're right. You're right. This will actually help a bit with our state synchronization problem here. Let's see, where did I put it? Is loading. And for people who've used React, this is actually beautiful, because yeah, React is useless without. Yeah, that's true. Use can't be used on its own. Yeah, that's a good point. Yeah, because use memo isn't guaranteed not to rerun again. Yeah, no, for sure. The reason I like this solution is this is what is it? Use deferred value, essentially. Like, now when I do this and I click it 5 times, it doesn't solve all the race conditions, but the loading state actually is proper, right? This is like a really simple version of use deferred value, right? Because you have the ID and the next ID, right? Like the kind of forked versions of the IDs. So yeah, this is kind of where a lot of complexity comes in, right? Because either you manually fork it and maintain the swaps of context, right, in a contained scope, or you do a general solution, right? The general solution is complicated, so I can understand why someone would want to step back from it. But I'm just saying, like, there's problems we have to solve here, right? there's race conditions in terms of the fetch. There's if we want to be able to do this kind of holding ability, we need to know exactly what's forked and contain that and handle the context switching. Like even with these simple examples that I'm showing here, they're not foolproof. You actually have to do more work. Which, okay. I'm hoping I've at least shown the general concept here and made a case for why these solutions exist, right? I'm not talking about, it's funny because when people talk about concurrent rendering in React, they talk about, time slicing and all that stuff. I don't care about time slicing demos. Honestly, I shared a clip up on Twitter a little while ago, but Aiden from Million and me had the very best time comparing Million to React Fiber time slicing, and it was such a great example or demo of things because I wish I actually had the demo still in front of me. I mean I could pull up the clip from Aiden's stream, but like I mean let me see if I can find it like YouTube. Let's go. Was it live? When I want to kind of, let's see, Aiden Million JS. There should be like a block VDOM, yeah. Yeah, I'm gonna play this clip for a minute just to refresh people on this topic because I can't emphasize this fact enough. Okay, I'm gonna change how I present. I'm gonna remove this for a second. Present. Chrome tab. Yeah, here we go. Let's do this. This little clip is just great.
Like an example like this seem even smoother. You care, but you can click the little. So when you say React versus Fiber, is this 15 versus 16 or something else special?
It's using the same version, but Fiber uses start transition.
Okay, good. So we'll see concurrent rendering. All right. Is this the idea that I'm supposed to do this like really, really fast?
You might need to put up the node count, so there's some more effects.
Okay.
Yeah.
All right. So I can add a 0. I can go like this.
I love this. I'm getting ads on my own channel. That's hilarious. It's.
Before you leave, can you turn that document into a PDF for me? Thanks.
I did it. I killed it. Okay, fine. Let's meet in the middle. 5,000?
Yeah. There we go.
I first want to say these examples are for concurrency are always so dumb because in order to actually do anything with them, you have to actually like pump the number of nodes out to some stupid amount that it's like pushing the CPU. And so it's kind of like, anyways.
Let's just
Yeah.
paint it red. Okay.
I don't know if people notice this, but every time I press the button on the stream, I actually lift my hand to try and show like the delay, but my hands even has a bit of delay on it, right?
It's better.
Mm-hmm.
This is the example I wanted. Thank you. This is exactly, you can see start transition already kind of making it. The big thing about start transition is I love this example because it shows it. Look, when I click this on React, there's going to be a delay, right? When I go to Fiber or concurrent rendering, there's still going to be a delay because even if it can schedule the stuff so it's non-blocking and keeps on spinning, it can't make the work happen any faster, right? Let's try million.
I really hope this works.
It does.
Okay.
And
Yeah.
there's less, but here's the difference. There's less delay. This is the fundamental difference.
Right? Like I'm not talking about the latency here on this spinner thing. I'm talking about between me clicking the button and seeing an update on the screen. I click the button, Concurrent React made it so that the spinner doesn't die, like the animation doesn't die, but there's a delay between me clicking the button and seeing the 15 or the 16 or the next number. Million, the spinner might chug a little bit, but there's no delay on there's almost no delay on my response here. And the original React is just like delay and chugs the like kills the animation.
Do you see? There's less delay here. I'm like trying to raise my hand so people can see the delay. Like even I go to Fiverr, which has the same looking graph. To be fair, like it doesn't delay it that much. Like it doesn't like trail that much. There's a delay, like.
Which is the whole thing is that concurrent rendering doesn't improve performance, right? Like this is why it like it still has to do the same amount of work. It just does the work off screen and lower prioritizes it so it doesn't affect what's on screen. So like there's benefits to it, but it doesn't actually make it faster. Right. I mean, the idea here is that you're supposed to assume that this thing that you're incrementing is less important, which makes these demos terrible because usually the thing you're interacting with is the important thing, right? So these demos are like sometimes backwards. I think that's why the Kaspersky's triangle example was used a lot because they tried to prioritize the animation and the clicking and hover over the numbers updating inside, which is actually more like an animation facet. So it like there's a conflict here, right? Like, which is kind of funny is that the thing you're interacting with, you probably actually want the speedy response on, not all like the background updates and animations, but the background updates and animations are the things that make your app appear sluggish, like noticeably, right? So Fiverr and concurrency from a performance standpoint is great in that it makes the app not appear as sluggish because the animations are smooth. And I mean, I remember doing this in React Native, not like concurrency, but the fact that like you did a lot of like work to try and make it seem smooth, even if the total output was slower. We talked about this earlier. It's the optical illusion of performance that matters to transitions, right? Because the things that you end up smoothing out it's usually like the opposite. Like it's like the background, like the thing you're actually interacting with is the thing you actually end up slowing down from like a total time period, but you make the whole app feel like it's smoother. So in a sense, it has a positive UX gain, but it doesn't have a performance gain. Okay, so I'm hoping I've made that part of this at least somewhat clear. Okay, so I think what translates to Git branches, you create a new branch, you need to fork one commit to build that. Yeah, I mean, my stream cover today was Git. Whenever I talk about concurrent transitions, I use Git as like my image for it because especially when doing concurrency in reactive libraries, like things with signals, it is way more like Git. But let's get there. Sorry, pun. Anyway. I think I'm hoping that I've established what transitions are, why they're important, and what they're not. When you can be looking at these async problems. So let's see where to go to next. There's been some good discussion on Twitter. LLM framework stuff, Ryan Florence. I'll worry about that later. Because I do have some. Oh yeah, we can talk about actions. Do I want to talk about actions yet? Yeah, it's one of the big topics here. I think actions is what we should talk about. But before that, all right, because actions, I'm just trying to like think of the order here. Let me just pull up my HackMD right now because I. Oh, it's been that long. Give me a second. This is what happens when I don't stream in 3 weeks. You can tell that I don't do most of my work on this computer. All right, we're in. Yeah, so since last stream, I've written 1, 2, 3, 4, 5, 6, 7, 8 HackMDs. But most of them are. I did a couple about firewalls and derived state. I don't think I'm going to get into today. It's safe to write to single and derived computation, VDOM as a proxy, non-reactive effects, dynamic optimized. Yeah, so half of these are actually about other design considerations. Let's see if this is a good place to start. Yeah, so let's just get into how one would design transitions. And I will publish this one out here. Publish. Copy link. I'll put it in here in the chat. All right. So I've kind of shown how we could mechanically do it manually, but how would we approach actually designing a solution like this? The way React works generally on this is they literally just fork the component tree from that location, like from that state change. So state change tied to components in React. So you know whatever you call set like inside the transition API, whatever state change you call, it's going to basically go, okay, from these components down, they're going to be part of a transition. Then it basically renders them off screen, collects all the async, all the use places. There might be places where it has to stop and re-render, because it throws, component stuff. But generally, it just kind of works its way down through that tree, re-rendering everything top down as it hits stuff and moves through. And then when it's done, it will say, look, this is the new VDOM tree, diff it against what's there, and show the updated UI. That's how I would summarize transitions, in React. And I mean, I could write that down if that helps people visualize it, right? No, I didn't want to move that. I wanted to move me. Yeah, let's move me. Yeah, let's do this. I mean, this is a grand oversimplification here, but generally transitions in React is like capture state, i.e. components that update inside transition. Defer until like defer to later, basically a render of these components off screen. Yeah, and actually, I want to take a moment to stop here because some people think that they solve transitions almost the way that we solve some stuff in animations. It's that like it's possible to hold values in the past sometimes by just keeping a reference to the DOM nodes and unhooking them from the reactivity system, right? And so like if you basically said, okay, I'm going to say freeze what I have there and then do update these states. So now the UI is not updating, fetch the thing on the next, page and then swap it in. That kind of visually might give you something that looks a bit like transitions. But it is not quite the goal here because you don't know how long that async is. You don't necessarily want to freeze everything, right? And I told you it's about right. It's global, right? It's not, you can't just, you can try and compartmentalize it, but then the second you have to go higher, you have to reformat that boundary, so to speak. It doesn't make sense to make transitions local. It's a write mechanism, not a read mechanism. So like, because of that, most proofs that transitions work involve having a counter on the page or a spinner on the page or something that's constantly updating while under the transition, because you have to show that both the future state exists and the past state is still updating at the same time. Yeah. It moves in reactive, which is not great because users sometimes change their mind when navigating. Yeah, for example. Yeah, that's a great example. Navigating, you click and then you go to click again, and no, sorry, we've detached the thing. Now, if it's an anchor tag, the browser might try and do its own kind of navigation. You know what I mean? Like do a full page navigation. But let's pretend we're using buttons or something. Like basically any action, you're allowed to like the page you need to be able to keep this stuff interactive. Otherwise, it doesn't really work properly. And I want to, this is why it's important to understand it's not simple enough to just, go, okay, well, this is the new branch. Keep on showing the old one, but kill it. Like that doesn't actually solve the problem. So yeah. So when the state, so capture state components that update inside the transition, which also involves like some sort of forking. I don't know how React does it or when exactly they do it, but you have to understand that the state that you write, like see, React always writes state in such a way that when you say set state, you look at the next line, you don't see the state update. So the transitions don't seem actually that jarring from that perspective. And it's kind of like you don't know when that state applies. So React has some kind of like, I don't know if they have to do forking at this point or how they manage that, but basically like keep the pending, don't apply the pending state. Right? Capture the state that changes and update string, but don't apply the pending state. And in React, it's pretty straightforward because again, there's no expectation of you seeing it during the synchronous execution anyways. But they have to know, like, don't apply it until defer a render of these components off screen, right? Collect promises, via use or whatever. Rerun render as promises complete. So this is like go to 2. You know what I mean? Like basically you do this loop while it's collecting promises rendered properly. This is why caching or like it's awkward because use memo isn't always enough. Like you need a way to make sure that like if you're fetching in the tree, you're not refetching and restarting this infinite loop over and over again. And then finally, when no more promises, diff patch tree, right? Diff patch live tree. Okay. Yeah. Main tree, whatever. Yeah, let's say main tree. Now, couple details that are important here is it's funny because React, when they first came out, they wanted to do multi-transitions, but technically, I told you solid release in December. We actually released our transition feature before Reacted. I was so sold when I saw those original demos. I didn't care about time slicing because people were like, oh yeah, this will solve React's performance. I mean, by now at the time people didn't know, but by now people know that when React says they're going to solve the performance problem, they're not talking about the performance problem you think they're talking about. They're talking about the performance problem of having 1,000 developers working on a project and doing really dumb stuff. They're not talking about making the framework at all faster. But everyone was like really stoked on that aspect of it. That was the least important part about this. As we showed, the performance is not even really something I'd be considering too much for most people, right? But the UX automation aspects of this, to remove the tearing, it's actually quite nice. So for that reason, what I was having some trouble when I was working through this and making it work right. I made a decision. I was like, how many features do we need? So I decided to make one feature in that December 19th 2019 release. I was like, let's do one feature. And React was advertising how they had all these multiple features. They had these really cool experimental docs that I used as a baseline to understand the behavior. They're not up anymore, but they basically showed suspense, transition, all the stuff. They kind of like the blueprint. Even back then, I was talking to Ricky the other day for the React core team, and he was like, Suspense always did this. And I'm like, no, not in your original docs. Like there was actually like a version of Suspense where transitions held even with new suspense boundaries under it and stuff. They actually shifted and changed the stuff during the experimental phase, which is fine. They made some really smart decisions there. But the point is, about, I guess, 6 months later, React Core, or when was it? Was it in 2020? I guess. Like I remember around the time that the React released the transition stuff under the hood. Maybe it was a year and a half later. I can't remember. They actually came out and like, we are doing single feature too. What does single feature mean? That means that there's only really one transition in the app and that concur at the same time. So like it only creates one. Yeah, back in the day when Suspense had a built-in timeout. Yeah, exactly. Yeah, that was the old version, because people, like, the original thinking was like, or there's like a global suspicion timeout. Like the original thinking was that like maybe it would be okay if, or that transitions should bail out after a while and fall back to Suspense if they take too long, right? Because again, there's no affordances for holding in the past, right? And it's hard to say like this is our default API when you have an affordance to hold in the past. You could, if you said it like a default timeout that says, look, after 3 seconds we're going back to fallback if it's not ready or whatever, then like people couldn't shoot themselves in the foot too badly. Like you still probably want a pending indicator, but if you said like, after a certain period of time, like, sorry, it's going to go back to fallback anyways, you're basically adding back affordances for loading without people having to be forced to add loading performance affordances. As I was saying here, you get to an interesting place when you have both, say, Suspense and loading affordances for transitions, right? Where you essentially have two different loading affordances. And I've struggled with this from design perspective over time, because there really are two different things, right? So like, 'cause sometimes like there's the stuff that's local to what you're doing, right? Which, Suspense can act as a version of it, or maybe, like your typical loading indicator, like, while you're doing something. But like when you're navigating to the next page, it's not localized. You're actually saying you're showing a loading indicator indicating that you're going to the next place, but the thing that's loading isn't the thing that's in front of you. It's the thing that's off screen, which means that the mechanism for loading indicators for things around transitions isn't localized generally. And it makes sense because again, transitions aren't localized, right? Like they don't have to apply to like where they affect the UI might not be everywhere, but conceptually they're global. So like it makes sense again that you can basically they'd have a different sort of loading indicator than asking if a specific resource is loading. Say transitions haven't been solved. You're talking about the browser, right? I mean, I'm talking about in the scope of what I'm talking about UI frameworks in terms of like, and I'm not saying solved. I'm saying like because we've been working on solutions on it. I'm just mean like what we're calling transitions here, which are kind of transactional. They're not quite transactional though, because there's difference between transactions a little bit, at least the way the stuff is working right now, which is actually we're actually almost at that point in the conversation here, right? When I'm looking at this in React, because if you have a single future, you can kind of cancel transitions, but once you layer them on top of each other, they become entangled. That's the term that we use, right? Because if you're doing a transition and then you add another transition, and there's only one future, conceptually, or one transition, then they all become the same transition, and it finishes when the last one finishes, so to speak. So like essentially, oh yeah, okay, well, locally, like say if you update root state instead of local transition project, yes. What I'm saying is it has, and this is more obvious from like, because React has components, so when you update the state, it belongs to the component, so you can say that it's localized to that. I just mean that the mechanism is derived from not where you do the writing, but from where the source of the write is from. So it could be root state, it could be global state, it could literally be, like it's not as tidy because like it can the classic problem, right? If you want to put something impact multiple places of the UI or be accessible by multiple places of the UI, you have to hoist it up, right? Or hoist it out, right? So like what I'm trying to say here is like suspense is very clearly, for example, a boundary where you're like, look, if I can't render my stuff locally, bail out or show fallback or whatever. Like there's no question there what the scope is. It doesn't care if you load this data over here, under here, over there. It's going to be like, okay, can I render? Yes, no. Transitions are kind of like they exist in space, like outside of the like you could write anything. That's what I mean by they're global. Like their application isn't necessarily global in the end, but their potential scope is anywhere. It's not like you're not just like, it's not like a UI zone region concept. Unless you force it to be. As I said, there are ways you can like say, I'm going to fork only within this context, like in a router or something. But your router in that case probably has to be higher level because it's the one responsible for doing all the transforms and handling all the forking for you. So then, and routers usually are top level, but I'm just trying to say like, this isn't, UI can change, UI can shift, the where you need to show something can change, right? And something like suspense is very clearly like these elements, this matters here. Transitions, it matters where the state is defined. Okay, so where was I? What was I? Sorry, I lost my train of thought here for a second. Was I looking at Twitter? No, not quite yet. Yeah, it's talking about the different loading affordances and how that's a consideration. Okay. Yeah, sorry, no stream this Friday. We Friday came early this week. Still, this is a fairly straightforward approach for React, because this loop that they get in from 2 to 4, while it has some new use considerations and stuff, once you get to 5, you're back to business as usual. So when designing concurrency in a signal system, it was a little bit trickier, and I don't necessarily want to get too much into. I'll talk about what I did in 1.0 a little bit. It'll come up, but I don't want to focus on. I want to focus on like what the solution should be. Now that we can have like a high level understanding of like kind of what React does, and like about when I'm talking about transitions being kind of a global thing, what I mean by that. Okay. I'm going to write out the algorithm, at least to plan for it, to make sure it sound enough. Pretty much my thought off the top of my head, so my perspective might adjust as I go on. And it probably has, because I've actually implemented stuff now. Start transition sets transition to be created on the next micro task. Create a global reference, including the transition queue, and run provided function. For those of you who aren't familiar, we'll talk about actions in a minute, but transition API generally involves passing a function that scopes some kind of write. Now, this is actually an optimistic state write, so that's not a good example. But I mean, I can show it in Solid's tutorials right now, right? We also have a start transition. This is Solid's API today. I'm a little bit proud of this one, because even though React had used transition, their original version had start first and pending second. And I actually was like, that's weird. It should be read then write. So I swapped them, and then React ended up swapping them when they released it. But originally they actually had them in the opposite order. But what the API, from an API standpoint, the way that we've been doing transitions basically there's some kind of start transition function that you wrap some kind of state update around. That's the gist of it, basic. And that way you can write state outside that's not part of the transition, and you can write state inside that is part of the transition. And again, this is important. I did a whole stream like a year ago about like why we can't just, there's the affordances I've talked about, why we can't just like make this the default. But sometimes like you don't want all the things to change together, right? You have to understand like there is context here that we can't just infer, right? So as much as everyone in the world hates this API, this is why Svelte didn't do this. They were like, it's weird to have transition and deferred value and all this kind of stuff. You know, we just want like a base model that makes a lot of sense. And I agree with them. I have to go back to here and be like, well, how do you handle all the different situations, right? And the answer for Svelte to async model is generally, yeah, you tear if you don't use their async stuff. Okay, that's fine. They bail out initially, similar to suspense. And then after the fact, they do a sort of localized holding. So it's not quite the same as transitions, but they make it so that like none of the components or everything basically kind of locks up until like when you do a set state change, until the async kind of comes through. And they look up at the compiled reactive graph to a certain degree to make some decisions there in terms of what to hold or not to hold. But like when the graph overlaps, let's say you're rendering the same section of the page or anything, it will definitely hold up everything in that zone. So it's not quite the same as transitions, because doing that example that I talk about where you like show the counter while you're transitioning can't be done within the same local scope in Svelte. They don't have a way of like, it's almost, they didn't kill the reactivity, but it almost feels like they killed the reactivity. Luckily, they give you an affordance by passing the pending into the block where you do the async. So you do get the ability to get the affordance locally this way, right? That's one of the challenges. But they basically have a kind of pseudo localized transition that's not quite as powerful, but probably maybe good enough. So as I said, you can always come back to this matrix when trying to like talk about async, right? Because this is really the only choices you have. It's a matter of coming up with reasonable defaults. And the first thing we all have to realize is if you do nothing in a framework, one is always the default. So if you've watched my previous streams in Solid, what I've actually done now is make one the default always when you're not using the async features, bail out initially, but then go back to one once the data is loaded. Because I had an interesting conversation, I guess, a couple of years ago with Dan Abramoff, and I was like, why aren't people using transitions everywhere? And he's like, actually, we think use deferred value is actually better for most like on-page mutation cases. And I was like, oh, that's really interesting. He's like, design systems, routers, yeah, transitions, but for most on-screen. And I was like, and yet use deferred value takes some thinking. Most people, when they're using these features, don't, and then just have suspension yank out on them over and over and over again. And then they have to learn this new concept. So I was like, if you've seen like the Solid demos that I did like a little while ago, we made tearing actually the default again, because that's what people are used to and what they expect. Which again, it's not consistent and it's bad, but yet it's the default when you add async to sync. So it seems like the most sane thing to actually do. Bail out when we can't render it, and then how do we solve transitions? Well, it's still a thing for those specific cases that need it, like routers and maybe design systems. But the average developer actually doesn't really need them for most things. So yeah, I still think it's important, but it's like, again, I'm using this as my kind of matrix to make these two kind of decisions. So let's get back into here. So where was I? Okay. Start transition sets transition next micro task, create global reference, including a transition queue, and run the provided function, which is that transition function I was trying to show here, like this function, transition function. Upon write, clone signals and all downstream dependencies. I said maybe during notification. I decided just to clone it first, then notify. Queue all these into a separate transition queue, which is separate from like the main reactivity queue, which substitutes. Collect promises if the transition function is async. We'll talk about that in a minute. Run the pure queue of the transition queue, which this is why we split effects. Basically, run the front half of effects, all the memos, all this, like all the what we call the pure stuff before the side effects. Basically, all the calculations. Any newly created nodes are not part of the transition and can be queued into child queues as necessary. That probably doesn't make any sense to you, but my point is you only need to clone the nodes that get notified. Any new nodes are just normal nodes and can just participate in the graph as normal. Collect the promises from any reads that are async. Like in Solid, we have create async calls. I'm actually not collecting the promises. This is what was my original thinking. What I ended up doing is, if you watch I had a previous stream where I showed off a cool stack blitz example in Solid. Stack blitz. Sorry. I'm just going to, I probably won't be signed into here either. It's been so long, but I won't have to sign into GitHub again. This one, hopefully. The dev example, yeah. Transition plus optimistic state doesn't mimic the tear approach. No, well, it's I was talking about this before, because transition plus optimistic state is like what I call kind of predict the future. In a sense, you're not holding completely in the past. It doesn't, because you have the future state presumably, or something that looks like it. It's kind of like this golden area, right? Because it doesn't tear because you have the future. So like I wouldn't consider that tearing, because user ID does equal user. You know what I mean? Like so it has the it's just, if number 4 is real, that is what number 4 is, right? Like it's basically this idea that you just have the things the way that they're going to be. You have immediate feedback. It gets more like bailing out, actually. It's more like this, but you have immediate feedback. It's consistent, but you can't always do it, right? I'd say tearing is more like where you, like, transitions always hold, except in the case of adding future stuff that could be there, which means that they can kind of close between holding and adding optimistic updates. You can close the gap between being in the past and being in the present without being inconsistent, and without being jarring. So yeah, I mean, this is the goal here ultimately. But yeah, I wouldn't consider this mimicking tearing, because it should, you should apply the optimistic updates consistently. You know, I guess there's a chance that you don't, but that's kind of within your control. Sorry, where was I? Yeah, this example. The dev example, right? Yeah. I use this example because, oh yeah, I'm gonna. Did I already change the I already changed the UI, the API on this? Oh well, whatever. The reason I wanted to show this example for a moment here is because it can, like, without transitions, this is tearing, right? You can see it. I'm showing a pending state. Yeah, it's sent to automatically randomly error, but it's showing a pending state based on the loading state of these async resources. So when you see, when I click, once it actually loads properly, yeah, here we go. I click, it grays it out, but look, 3 updates immediately before. This will be 4 before this becomes 4. Look, 4, 4, right? So this is tearing. This is the default. There's no transitions. I'm just, going, hey, is this pending? This one resource, loading state. So this is how you do, I'd argue, this is how you do tearing right. Whereas if this was a transition, these two would be locked together. But for a lot of people, all they care to do is go like, okay, I got, an ID, I'm going to create async, I'm going to fetch something, and then I'm like, show me a loading indicator, and I'm done. And then I'll wrap the whole thing in suspense, just so that when I load the page, it can load stuff, right? There's a bit of a cascading waterfall for streaming, but then after the fact, I'm not falling back to suspense. As I said, if this was React in this example, we'd be yanking out to suspense every time we click the button, right? So this is what it looks like to have tearing by default, from both a UX with suspense, with a UX thing. So I'm pretty happy with this, but I do recognize that while this is good for 95% of what developers do, things like routers, you want to handle more holistically, right? You want to have transitions. I understand that you don't need, like, this is pretty good. Like, stop erroring. It's like the random error thing. I got that from Ryan Florence from Remix. They always feed errors into the demos, which I think is absolutely genius, because you should show race conditions and error stuff. This demo is still useful, dev. Anyway, so, but my point is, inside our rendering, like, we have, like, these compile into effects essentially that have a front side and have a back side that does the actual DOM updates. So what we can do here when we're designing our transitions, the reason I showed this example is actually the error boundary. Sorry, now I remember. I realized that our suspense or error boundaries, like, and this works the same way with error boundaries as well. Error boundaries actually make a really good example for this. See how this is errored? The error boundary is down here, right? The data fetching is up here. How is it that when I press this retry button here, it's actually able to try and like trigger suspense and load the data again? Data fetching up here, error boundary down here, right? On click reset. What does reset do here? It's actually just something being passed in from the error boundary. So how the hell is it doing this? Well, it's because the way the error boundary works is it actually collects the errored out effects nodes, the pure parts essentially. And then when you click retry, it goes, okay, these are the errored effects that can't render. It just reruns those nodes and pulls all the data again, which triggers the async to fetch again if it's errored all the way up the tree. If it stopped somewhere else or there's somewhere else, it's not going to get up there. But it literally pulls down the specific reactive graph to be able to rerun it. And suspense actually kind of works similarly. We don't collect the promises, we collect the effects that are not ready, essentially, and go, okay, let me know when they are ready. You know what I mean? So like, as they complete, as they're able, like their async dependencies update, they schedule, they clear, and they go, yeah, I'm good. They remove themselves from the suspense boundary, and the suspense boundary goes, oh, I'm good, I can show myself, right? So like this error boundary has this kind of similar dynamic here, because either you click retry, which pulls, like I mentioned, or when you're navigating to the next page, remember this is solid. We're not actually recreating all these components here. They're actually like swapping under us, right? Like here, there's no show. We're actually keeping these same elements as we're going to the next one. Obviously, like when we show the fallback, we lose this, right? But what I'm trying to show is when we click the next button here, it also ends up causing those effects to rerun, which also remove those nodes from the error boundary. So both the retry and the move forward next work without rerunning or re-rendering any components. And I thought this demo was crazy to show the power of this, but this same node collection technique applies to transitions as well. If you tear an async file, when you're stuck in an error UI, yeah, you could. See, I'm not actually sure how much rollbacking is actually happening. That's why I see a big difference between transitions and transactions. I mean, let me explain a bit. When you have a single feature, like I'm talking about here, like React has and Solid 1.0 has and whatnot, as soon as things become entangled, you can't really roll them back. You have to roll back the whole thing. But what if the first thing passed and the second thing failed? Now you can't do it. I think the whole hope of rollbacking transitions is a pipe dream. Honestly, I think this is more of like a good way to handle scheduling of async tasks and less of a transactional model. I think that's why I was working on solid transitions and I called them transactions, and I'm like, no, these are not transactions. I think it's important to understand that. I mean, React talks about them like they're transactions. And maybe React's approach to multiple that they're working for is kind of working on transactions, but it's very, very difficult to unentangle something. And if you don't entangle it in the first place, you have to almost enforce order, which means that are we going to be sequential? Now, if you're a database or something and you're close to where the right point is, and you can do that, you can go, look, I'm locking this, classic transactional model. But when you put a network in between you and this operation, yes, in theory, but I'm saying I don't think you can even do that. I think you just have to go with it. we already have things like error boundaries and suspense to handle the odd cases out and whatnot. I think it's an odd scenario to be in, to say that like for sure that like you didn't want any of this to happen. Like what if you like updated the database and then did this? Like if something errors, you are in a screwed up state regardless. And I think the UI probably should reflect that. So like, yeah, we're gonna get there. The implications of it in a second. Collect promises, transition async, blah blah blah. Reasoning. If promises are not all resolved by this point, do not run the effectful side of effects. When promises resolve, restore transition at each point and start from 3 again. So this is the loop. On the React example, I set it 2 to 4. Here's 9 to 3, but it's the same loop. Eventually, all the async resolves, and we are at the end of the pure queue. Merge back the clone nodes and run effects. So it's kind of the same thing, right? Like you can see that there's differences here. In React, their rendering, like their whole render tree, is the pure queue, and in Solid, I did a great diagram a while ago. I don't think I have it in Excalibur anymore. I mean, I can try zooming way the hell out and see if I actually have it on here, but I don't think I do. No, it was on my old computer, where essentially I was comparing the timing of split effects with the timing of like React life cycles. You can view the signal graph up to the front side of effects as basically the same as the React render tree. And then the back side of the effects, basically the equivalent to the diff and patch. So by doing scheduling this way, you can basically do a granular, more like granular, non-component based version of basically the same thing, right? You follow the data instead of the UI tree, but it's essentially the same thing. Well, the benefit of this decoupling is you don't have to re-render components to do stuff. Yeah. Get not post. And to be fair, post is a big pain that we're going to talk about in a second. Because the beautiful thing about get is we haven't showed this in our simple playground examples so far, but you can see it here with like create async and stuff. Is we can see the trail. Like if get phrase here is based on count, we know at the point that you call set count here, like this is where you'd wrap the transition in this example, right? When you click the button, you update the count, you go transition set count here. When you set this count on the get side, we know that this depends on count. So this depends on count. So where else is phrase? Or this depends on count. This depends on count. This depends on count. This depends on count, which means this depends on count, which means this depends on count. We actually built out our whole dependency graph, and we know it right from the point of doing that, either from setting it here or from setting it in a transition. We can actually see the whole dependency graph of everything that would be impacted, right? And this, again, this is a superpower of signals. So where are we here? Yeah, what did I say here? A lot of details. Start transition, set transition. Start transition sets transition to create the next path. We do this to finish the current execution, drain the current queue before starting. Even chain queues should run synchronously after you're running the queue, so except for additional transition fire at the right time. Okay. What I mean by this is I realized something while I was working on these things that it's kind of awkward. You want to drain the queue because if you're going to clone the nodes and they're already in a notified state, then you have to be responsible for running them on the transition branch. You actually want the queues to be completely drained at the time that you create a transition. To create a global reference, including transition queue and run provide function, we need both an active transition and for all current transitions. Okay, so I'm already suggesting at this. There's nothing about this solution here that doesn't allow for multiple transitions, right? There's nothing really about this that doesn't allow for multiple transitions at the same time. The challenge with multiple transitions is managing entanglement, right? How do you know if these things are like should rely on each other or related, right? You don't want to like finish out a transition and have, you know, something else working on the same data at the same time or trying to pull at the same time and then having them kind of like do a weird like you could end up with tearing again, right? So how do we like you know, like if you fetch something based on two signals and one updates in a transition and then another one updates in another transition, you know, like you don't want to be in that intermediate state. You're like, okay, fine, I'm gonna have to wait till the final fetch. Like in that case, you end up fetching twice because they're two distinct events that triggered those two transitions. But you should know that like it's the like you want the one at the end that has both state changes to be the one that reflected, because if you kept them separate, again, and we'll talk about this more when we get to actions, it's possible, given async timing, to get unexpected results, like the second thing to apply before the first thing, or you know what I mean? Like it's you show, like in this example where there's the two different things, you actually like show it in one half state where it's tearing all over again, essentially, even though it's like done during async time. It just, you don't need those intermediate states in the UI. So yeah, yeah, I have some details here that probably not too important. Upon write, clone signals and all of the stream dependent cloning. Let's talk about cloning. We want to clone them back to basically initial state. We don't clone cleanup or children. We need to backlink dependencies and observers, though, since it's possible for the main thread to cause an update that trigger these. So any new clone is going to clone observers, but it needs to add any clone of those observers as well. So yeah, this is kind of a fun little graph I was playing around with, kind of trying to understand how to do this. Because when I started cloning, I was like, okay, I'll just clone all the links between these things. But if you've ever seen a signal system, they dynamically manage their sources. So you can't give a parent, multiple versions of the like different sources, because depending if the main branch or the transition branch reruns, you'll delete the other half. It's kind of a funny problem, right? If you try and clone everything, not everything gets cloned. I'm only cloning things that are direct dependencies. I'm not cloning, like it's possible to have a source that's outside of the transition. Like here, that one's not going to get cloned, even though like this is the thing that you edit during the transition, this part of the graph. Then you have to clone on the downstream, but the downstream can rely on things that aren't part of the transition. And those things can still change while the transition is going on. So it's important to understand that like, it's a little bit tricky here, because every time this reruns, like maybe these arrows are the wrong way, because I'm basically showing like this is a source of this. So it's more like that way. It's the source, the observer array needs to include both versions, but the source array needs to only include the original and then backlink through the transition version. This took me a while to figure out, admittedly, but the end result turned out good. The other thing that I realized, and I mentioned here, is that we don't clone cleanups or children. Because the child is running on the transition branch, you don't want to clean up the currently visible branch, right? So when you clone it, you can't, you treat it almost like it's new again. So it can run. And then when the final thing merges and goes, okay, I have the new version of this node and the old version of the node, at that point, you call the cleanup on the ones that are there on the main thread when you merge them back together. But the funny thing is, in the middle, those things could update, right? So they could run their own cleanup functions, you know what I mean? And inside the transition could also run its cleanup functions. It's not just the original state. These things are live nodes. But it's important that when you start the clone doesn't contain either the children or the cleanups, because you don't want to clean up the original. Merging on clone, right? Other condition here is if a write would cause a transition to become entangled. Yeah. So you start one transition, you start another transition. How do you decide if these are independent transitions or these are the same transitions? Now, I'm taking a single future approach still here. I think I realized as I kind of are walking through this, right? A single future doesn't mean you can't have independent transitions. It just means that if things overlap, then they have to be entangled. And the benefit of single future is there's no complicated merging problems. You don't have to worry about what do you call it? Like sequence. The individual resources have to worry about race conditions, like the async parts. But the whole graph doesn't have to worry about the sequence, because async, it's hard to decide what the sequence is, right? Because it's like, who wins? Like, because there's the thing that started first, and there's the thing that ends first, and those are not always the same thing. Do you apply them in the order of what started first? Like you have priority, you have a lock until you're finished. Well, then you're completely sequential, and that really sucks. Do you for a lot of things, it's hard to make that a default. Do you just, does last one win? Kind of, but yeah. What if something cancels in the middle? Like there's a lot of complexity there. So what I realized as I worked through this was I'm actually talking about single future, but there can be isolated parts of that single future that can update. Yeah, maybe we do it ends last. Yeah, right. That's probably the most sane thing to do. But as I said, it's interesting because that's the easiest way to kind of clobber or kind of like come in. And I think you have to. So the trick with single future is if the things overlap, you just assume that anything coming in will like become part of the same thing, and then it gets incorporated. Because if you have two different things going on and they overlap, they're not going to see each other, right? Like this includes like this sort of scenario. What if someone updates this in a different transition now, like this outside one? It's not going to, if you don't entangle them, it's not going to see this change. It's not going to know that this one's changed. It thinks it's its initial state. So it's working off here one tree and it's working off another tree. Now, maybe in React, they don't mind like having all these predictive futures and then like merging them at the end when this one finishes and then this one, and then figuring that out and like apply. Like, I don't see how that doesn't cause 3 different fetches, right? Like if this is an async thing here that fetches, so initial state, good. Transition on this comes in. This value, new value B, old value A, fetch 1. Comes in, transition, doesn't see the other transition. New value A, old value B, fetch 2. 3. One of the transitions finishes and he goes, okay, like whenever it goes to merge, it's going to eventually have to do new value A and new value B. Yeah, I mean, if you want to control how the merging happens, there's also other ways of doing this too, right? Like I'm not too worried about like the API aspect of it. Like you're saying, like give people the control whether to name it as the same transition or not the same transition or whatnot. But like I'm just like they have to be cognizant of the shape of their graph, and then you're like, okay, well, just let them kind of go with it, I guess. Right, like you could do that, and give them all this control, but like what, like I think you have to really question whether you want, like this is already a very complicated and advanced API to use. I think it is potentially very error prone. Whereas just kind of going like, okay, we know what overlaps is a very straightforward way of just saying like, because like the worst case scenario is the way that transitions work in frameworks today. The best case scenario is that the things that are isolated are able to run out early. And like I don't actually think the current state of single feature is actually that terrible. for most things. We'll get to where the issue is in a moment, but it is worth pointing out that if you entangle them, or when you hit the state, then it does fetch a second time, because basically this transition becomes based on the top of this transition, right? Because like if you kept them separate, right, then they could, and this one canceled, then you're also in a weird three fetch state, where this one will fetch twice. You'll originally have old A, new B, and then when this updates, it'll have new A, new B, because you've entangled them. And I think that's fine. The thing is, you won't get a result until you get the new A, new B result. You're not going to get the result on the first part of the graph, but that's, I think, fine. Transitions are complicated when reference is having trouble with them, and he's the guy. He's affected. Yeah, I mean, this is a tricky topic. If I think there is a potential future where React does go to looking at them like transactions. As someone who only cares about the UX aspect of it mostly, I don't know. Let's see. I can't make conclusions until we get to the end of this. The other consideration here is if cause transitions to become entangled, become the same transitions to distinct ones. If you were to write any of the same sources, it definitely would, but would isolate signals have to read the same computations? And I think I just answered that. Yes. I do talk about this. The approach we're talking about has no explicit cancellation, only merging. You can only move forward, not backwards. This is the way the React system typically operates and should continue to. In the case of these pseudo cancellations, the transition might linger longer than it needs to, but it will essentially die on the final merge. Yeah. Queue all of these to transition queue. Yeah. Collect promises transition is an async function, right? This way we can capture promises actions as reads. If we want subsequent state to happen inside transition, we wait, we need something. Yeah, I started talking about this API. It's not my favorite, but we can't re-inject our context after an await without passing the function through. And this makes the same transition. Again, using names or some other mechanism could accomplish this, but the idea here is you can go set some kind of optimistic state or something, await saving the database, resume, set some different optimistic state maybe, and then await something else, do a sequence of things. We don't have to worry about chained awaits because the transition will wait to get the whole promise back. Yeah. There's some thought whether the resume function should have its own resume, etc. But I think we can make it if you call resume with an already complete transition, it errors. Okay, fine. Run pure queue with the transition queue, and any newly created nodes that are not part of the transition can be queued as queues. I haven't figured this part out. This is when we get to suspense. We'll probably talk about this. So I'm not too worried about this yet. Collect promises. I already mentioned how I'm going to use nodes to collect the nodes, not ready nodes. So I guess it isn't promises as much as not ready effective nodes. If promises are not all resolved by this point, do not run the side effects. That's a simple check. When promises resolve, restore transition at each start point. This is interesting since only collecting initial promises from transition resume. So we need to be able to handle the checks as well as be able to drain anything to schedule the transition. So it's a bit too pronged. Yeah, basically what I did is I have create async when the promise comes back. If it was created, if the create async function, like here, like if this function here runs during a transition, when the promise comes back, I just call resume on that transition. And that basically allows it to go. It basically does a second round of cloning from that point if it needs to. But they should already be cloned from the initial notification. But it just basically lets the rest of the graph continue on. It could be controlled over generators. I looked at that API, right? Because the only problem with generators is TypeScript, right? Let's go back here for a second. Because if you yield a promise and you actually need the return results for it, TypeScript is a pain in the ass for this. But yeah, people would have to get used to yielding promises or values. But yeah, people have to get used to yielding promises. This is what MobX does in their flow component. I did definitely look at the MobX flow component for inspiration, but it was like the thing that people are secretly hoping for is that when we get async local storage in the browser or async constants in the browser, we won't need the resume function anymore. We'll just be able to assume that we can inject the state again after the await. The yield syntax, I don't remember where I was concluding on that, because I definitely, you know what, let's open HackMD. I think I actually had a whole HackMD just about this specific API shape. Where is it? Yeah, I have a whole hack on MD on how to. Okay. Yeah, let's talk about that right after this one. But yeah, it is possible. I identified, I think, 3 different APIs. I finally decided that this was the lesser evil of them. Again, TypeScript is just miserable when you're trying to design systems. Run pure queue as transition queue. Any newly created nodes are not part of the transition. That's fine. Where did I get to? When all prompts are resolved, merge back and run effects. It's at least more straightforward. We get to the point existing nodes can be merged. Takeaways. Okay. We only need to clone nodes that are notified during the transition, since we discourage writes and computations, which I've actually added a warning to in Solid 2.0 right now. This should mainly be in transition or resume functions, firewalls, or in firewalls when draining the pure queue. Everything else can be created as normal. When cloning, we don't need to clone children or cleanups. These will be created when it runs and don't want to clean up the original. Since this is a variation on a single feature, even if it can be discrete parts, we only need one transition-specific node cloned for an existing node. We have to be conscious of keeping independent graphs while still being able to notify from the main branch to the transition branch. This might take a little bit of fiddling with how we do the linking and lookup. So yeah, I actually solved all that, and I'll show that in the code in a few minutes. But this is the core idea of how you can do transitions in a signals-based library. It was funny when I first did concurrent in Solid 1.0. I remember people, like very influential people in the React community, basically saying it wasn't possible to do with signals, and I'm like, no, I've already did it. I did it like a year ago, and they're like, no, blah blah blah. It's not. Like literally just kept on repeating the same thing. Like Paul Henschel from 3JS specifically, and it was like, no, I've remade your concurrent demo. It literally works. I showed it to you multiple times. People really had a heart disbelief that you could do this stuff without the VDOM. We already did in 1.0, but I think this is going to be better with this ability to isolate based on the reactive graph. We use the same technology, as I said, to figure out error boundaries and suspense. So why not use it here on transitions? Yeah, if you add an additional wrapper function, I don't know. MobX hasn't solved this to this day. There's a very, very long thread, and I just was like, if nobody in the MobX community have solved flow functions, I am not going to be the one that's figured out. Right, like you can type generators, but can you type it so that it knows that anytime you yield a promise, you actually get the value? Like the reason is you do something. It's kind of weird what you do, because you basically, what you're saying is, I want, because you don't want to go yield away. I don't think that's a little bit too clunky. You want to go yield this, but it might be like the code you might end up with might be like, drop it down here for a second. The code you end up with might be something like this: yield. To do this is right. It was getting this to be not promise of this value, but the actual value of it. Yeah, no arrows for generators is annoying as hell too. Oh, it's yield star. What's yield star? Yeah. Oh, it's yield star. My bad. Whatever. You get. But yeah, this getting this to be where is if you do this, like you will get the proper type, assuming that this is this. Anyways, that MobX has like literally a 3-year-old, like 4-year ongoing thread without like hundreds of responses in it that no one's actually solved this problem adequately over the like last 5 years. I think there was a trick because MobX uses classes that they could build it into like the class types or something. But like from the pure function standpoint, it all involved like adding functions just for the sake of TypeScript, which hurts me deeply. As I said, I also am hurt deeply that TypeScript impacts the shape of API design. TypeScript is, as I said, very, very annoying for designing APIs. Yeah, exactly. Like you pass into a function to get the function to get the types. It's doable. It's just again, if someone says you need to wrap something in a function for it to work with TypeScript, then yeah, I'm like seriously, because then now it's like, oh, is this a function that we also have to send out as a part of our library for type so that people can do this? It's just like, I know people are used to doing this in TypeScript, but and maybe I should be like, take that stance that TypeScript users are crazy. It's just really dumb when you hit issues like that. Anyway, right. Let's talk about. So I introduced a moment ago that, what if how do you deal with showing pending state for transitions, right? That's kind of like the next topic here. It's very relevant for optimistic updates, like for like actions, which React calls the actions like an async function passed to a transition. Solid, we had a special action wrapper, and I think Svelte Kit ended up using the same approach Solid did with the action wrapper. Remix has those like exported functions, or sorry, React Router 7 version, whatever, has the exported 7 functions. But like, generally speaking, conceptually, there's a mutation part of this transition async part of the story. Both of these problems actually are kind of similar, and React actually might have come up with a really elegant solution to it. I was talking to Ricky, and he convinced me. So let's talk a bit about this, because when I first went into transitions, what I kind of wanted to do was like basically await transition and go like set pending, await transition, set pending false, like as a way of handling it. And then I was like, ooh, the await's too late after the fact. So then I was like, what if I make it a callback? So like when transition function, and then when transition done, callback function, then we can call it synchronously, like before the transition ends, right? Because there's this time period between when you've done all the pure calculations and you haven't applied the effects yet. It'd be really nice to be able to like do a few more updates in there and then apply the effects. If you do an await, it's going to be after the render, so it's too late. Right. So here, set pending true, transition, set tab B thing. That's my thinking. Right. And I think I was also really interested in Vue transition API. I thought, I don't know if people are familiar with the Vue transition API from the browser, like start Vue transition. Again, a different type of transition. But the idea here is you can do animations, and then when you call start Vue transition, it basically starts doing a snapshot of the current UI. This is a lot like the freeze the UI non-updating thing. And then when it's done making the snapshot, it calls your update function where you can apply your changes. And then when your changes are done, it will transition the UI from A to B. Now, great API shape on the surface. You're like, oh, this is great. But kind of awkward. Because I was like, okay, wouldn't it be cool if we could just like make transitions work into this automatically, right? Because first of all, start view transition is not synchronous; it's async. So if like here's a problem, and this people will do it today. They'll start view transition here somewhere, like out here when they do the action, when they press the button, when they go to click save, and then they will await the transition stuff inside the callback function. So it'll snapshot, and then it'll start the transition, call the callback function, realize the asynchronicity of our transition, and then when it's finished, it will do the transfer, which works. But it means that between you first clicking the button and this finishing, and there is a bit of a delay because it won't call this start transition right away, like because it's async, but it freezes the browser. So the whole time it takes for you to fetch your data to get to the next page, like or on the the update, it froze the browser, the thing we didn't want it to do. You don't want this function to really be async, or if it's async, it should be like immediate micro queue. You don't want this to be waiting, because once it's done its snapshot and it calls this, it expects to be like to animate. The time between the initial call finishing and or basically the whole time it takes for this to finish, including the async time here, if your update callback freezes the browser. So you shouldn't be using view transitions that way. But it means that it's freaking awkward timing, because the ideal time to do this is to call start view transition right when you're done the pure queue, but before you've run the effects, and then run the effects in here, except this is async. So you actually are in the middle of the framework's render process, and then they're like, oh yeah, we're going async now. And you're like, no, but I have to apply my stuff synchronously. So you be like, oh, maybe it's an I call you kind of situation where you give them the ability to call your effect renderer, whenever they finish their snapshot. It's weird. Now, there's ways around this. You can like maybe provide an API where you could pass in like a promise that you can basically pass into here. So like you do your render synchronously immediately, but when your render, yeah, I mean it's tricky timing wise, because this is async. You have to kind of await them taking the snapshot. Let me think here. Do you have to wait for them taking the snapshot? No, they can take the snapshot immediately, but you have to make sure that you don't render your effects before they finish taking their snapshot. So yeah, you do have to kind of wait them taking the snapshot, right? So even if you could say like, look, you don't have to call my render function. I'll just call a promise, that I pass into you when I'm done rendering. This still can happen too late. So like, and Ricky pointed out too, when I talked to him, that sometimes for things like suspense, like fallbacks, you want to use view transition, which have nothing to do with transitions. So like this wasn't the right fit, but I definitely was looking into this, because in my head, I was like, oh, wouldn't it be cool if you could just call start view transition right here in the second function in between when the like pure part and all the async resolves. So you're not holding the page while the async resolves. And then right before you actually merge in the transition effects, do the view transition. It seems ideal. The problem again is because it's all async, it basically won't play nice with us. So we have to kind of come up with our own solutions there. But yeah, I realized that we can't just merge these things together. There's places you want to use view transitions that have nothing to do with transitions, like with suspense. And the fact that the start view transition is async is very painful for frameworks. They need the special case, which means you probably can't just hand this out to the end user to use the native APIs. You have to wrap it yourself, maybe in like a view transition component. I know, a little tangent, but I just kind of want to put that out there, that like these are the kind of considerations that go into designing these API shapes and stuff. And I was really hoping for like, oh, look, we just use the native stuff the way we want it to. Unfortunately, the native stuff is designed in such a way that is very awkward for UI frameworks, as usual. But again, it's a very difficult place to be to kind of figure this stuff out ahead of time, because someone has to propose it and then be very involved with trying it to kind of figure this out. And it makes sense why this would be async, because taking a snapshot probably does take some amount of time. Maybe not a huge amount of time, but it takes some amount of time. But can we guarantee, like, the snapshot happens before we render the DOM on the same synchronous task? I don't know. I maybe it does. Like, maybe the starting is enough, and the waiting is just when it finishes. Maybe this is worth like looking further into the spec. That being said, as I said, it doesn't apply for suspense, so I'm not going to worry too much about it. It doesn't belong as part of this API. You know, we could look at having a specific, like, maybe like on, you know how we have on mount in Solid, like that it runs right at the while the effects are running on the like after the render effects. Maybe there's like an on before render kind of cycle, and if this does work in a reasonable way, then we could just hook in to that life cycle and then kind of use our same scheduling queuing mechanism, so that like you can call this function when it's off screen, and then when it goes to like merge in suspense or transition, that's when it actually runs, because it's scheduled to run at that point in the life cycle when it actually mounts, so to speak, or renders on screen for the first time. So yeah, I think there's like potential here, but it doesn't make sense to bake it right into transition API. Okay. So it's worth noting that React has something called use optimistic, which is like ephemeral state. It handles all pending states around transitions, converting into an equivalent solid with something like this: create optimistic, false, true. So the way the React version works is you just set some pending state, and then at the end of the transition, it gets reset to their initial value, right? So instead of having, you know, this before and after thing, you literally just go before, you know, and then when the transition's done, it's over. It automatically resets the base value in the transition ends. You can also make the base value derived into immutable overrides. So yeah, in React, they have this thing where you can actually base it on like a list and then like merge the stuff in. And this is actually kind of interesting, because I was thinking, I'm like, what if you made this a reactive list and then pass that list in and then apply the stuff in? But since it's reactive, but what if it's immutable though, right? Every time you get a new to-do, you're cloning everything, right? What if we just made that mutable, right? What if secretly under the hood, only when you add this function, like here's a signal, here's the signal version, it just swaps a value, right? Set pending, set false, right? This is like a signal, right? It's very clearly setting value. But when you add the second function here that does the diff, what if you just made it a projection? What if this is derived mutable reactivity, like we've been working on the last couple months? Then this gets interesting, because you can apply these once, do the fine-grained updates as you mutate it, and then when the transition ends, just diff back automatically. This is the Strello demo in a really, really clean API, because you could just like go, okay, if like this add to do doesn't have to be add to do. This could be like any number of actions. You can be like add to do, new item, do this. This is the mutations that come in, and then you write the merge function right here, and then you don't have to call reconcile yourself. It just basically all works and cleans up itself when the transition's done. So you just literally have like a switch statement of like on the different actions that happen. And the cool thing here is, instead of on every new one you clone and stuff, you just do the one fine-grained update, and it will only call it with each message once, and then apply each fine-grained update. And then if the optimistic update matches the final return value, then hopefully when it diffs back out, it will match and do no further work and not re-render any more components or whatnot. So this kind of gives you back fine-grained updates with optimistic. There's no cloning or, you know, kind of weird merging, and it makes use of the projection technology that we've been using under the hood. What if transition returned a promise for when it finishes and attaches? So you could do something like start view transition. Yeah, the problem is, and this is how people do install it today, but you understand the problem here is this awaits for the whole thing. Like, what if there's async happening in the transition? The second you call start view transition, the outer view one from the document, it freezes the API, which means that the whole time you're doing async, it actually freezes the UI. Like it's not interactive anymore. You want the time inside the callback to be as short as possible. So you basically want to do the transition, resolve all the async stuff, then call start view transition right before you actually do the rendering. But because this is async, the start view transition, there's like awkward timing where you don't want to render too soon. What if the transition fails at some point? Will it revert to the state? No. Yeah, I think I already kind of went through this. Yeah, I mean, if it fails, you mean the optimistic state. If it finishes, failure or success, it will revert. It will revert the optimistic state regardless. Optimistic state is just, it's like pending here. It's like it was pending, now it's no longer pending. So yes, optimistic state only lasts the life cycle, the transition, success or failure. Basically, what I'm arguing is transitions can't fail. The operations inside them can fail. The way you render everything can fail, but transitions themselves don't fail. They just they don't error. They basically happen, and they complete successfully or errored, but they don't fail. They're just a scheduling mechanism going point A to B. If you remove the transition, it's the same thing. A to B. You can't. They're not transactions, right? But yes, it will revert the state on transition end, because this is using projection, which means that it is what do you call it? It's derived, so it doesn't. If you can see my recent streams, it doesn't actually mutate the source data. It actually creates kind of reactive wrapper around the source data in a super fine-grained way. So yeah, not my last stream, but the stream before, I actually showcased how we could do derived fine-grained reactivity, and this is like a perfect use case for that, because it basically doesn't impact the it doesn't impact the underlying list, so you can always just get back to it. I see two benefits of this API. It separates the two halves in a way that makes the logic seem simpler. It hides the implicit diffing. Secondly, it turns updates back into events. It doesn't assume you want the form data, you decide. It also doesn't care the shape. You can merge it with the actual list or keep it a list of optimistic things. You can have one handler for multiple messages or one type of handler. The biggest question, as always, is there a more basic primitive here to just handle optimism without the projections? In reality, solid, you'd almost never want the immutable form for anything with any depth. Basically, if you far enough to have a diff function, you want projections. So maybe that's the stance. No incremental function without it using a projection. But that's not true. I actually figured out a solution to this. We could have the setter function pass in the previous state. So if you want to do immutable diffs, it's like solid signals. You could have I think actually I have this in a different HackMD. Sorry. I should actually publish this one. Sorry, share the one I'm on right now. Publish. Sorry. I should have copied this into the notes already. But the other HackMD that I'm working on right here, yeah, I realized that we could also have the setter in the simple non-diff function version, like basically on the signal version. We could pass the previous value in, so you could merge it yourself, which is slightly different than passing the diff function version in, which uses the projection in the middle, right? You guys can see the difference here. This one, you just like pass in the item. That would be the new item. You do the merge in the projection, which is a mutable, and then the setter function with the previous value, this is it's like a single signal setter function essentially. So then you could do here with the simple version. The difference is this merges it with some actual derived state, you know, and then like you would use this if you were just collecting the messages. Like in Remix, the to do demo, and this is the same as Solid Start, we don't our use what's it called, use action or use submission, use submission pulls out optimistic data almost in this form where it basically pulls out the list of messages, like the things that you save, like each entry you submitted on the form. It doesn't merge them, and then you use this ephemeral state to merge them in the UI. Essentially, like you go, okay, well, if I have a to-do list and I want to have I have an add to-do action, you basically, as it's going, you add the to-dos on this state, and then you have a second for underneath looping or map function looping over the new to-dos. So the original to-dos are untouched and the new to-dos are added in the end, and this only contains the new to-dos, and then when it finishes, it clears it, right? Whereas this version, you would actually pass the original to-do list in here and do the merge in here, you know, fine-grained style. This is better if you want to like in the Strel demo where you're like moving stuff between board columns and want to do all this stuff, but then everything basically feeds through. Like I call this optimistic only, but like you could, if you did it derived, like in this version, this isn't optimistic only. This is list with optimistic if thing. And then from here down, you use this version of the list instead of this version throughout your UI. Like that, this version actually merges the changes like as part of the primitive, and then you render the merged the previously merged changes, right? As I said, this is great for the simple case. It's the way actions work in Solid Router. This is much more powerful and making like advanced optimistic UI updates, I'm not going to say trivial, but much easier to get right. Second, are these localized? Our current API has a nice trade-off of being declared globally. I guess our action could still work this way. Yeah, I was basically showing this, but actually I think the action API would probably work like this. But yeah, I'm showing that we could keep Solid's current action API in the router built on top of this. What's cool about this though is if you look at it, you know how today our transitions return pending? You know, this mechanism works for both optimistic updates and normal transition like pending states. And I think that's pretty powerful because you control what's pending. The thing that's always bugged me about like is pending or returning stuff like that is like now if you want to do something special with it, you end up having to derive from it, where a lot of cases maybe you just have two states and you can just feed them in here yourself, you know, like these optimistic states. You don't have to like try and derive them from a signal to give you. You're the one who gets to choose the signals. I think this is a much more sensible API. I was already getting away from our current transitions, like returning the pending state. That's why I was like looking at stuff like this, where it's just a signal. But I think this is actually even better. Managing errors. This all works nicely for happy case. How do we see errors? Things on the read side naturally error when they're used. Things on the write side have no such ownership. I don't know if it's responsible for optimistic updates to contend with that, but historically they have for us. I think the answer most of the time is you don't want to upend the rendering. So the key to this actually is how you manage to return value from the action itself. So the idea here, yeah, is when stuff errors, actually this should have probably a resume in it, but when stuff errors, handle it in the action. Not don't expect the, again, if we make a specific solution for the router, like we keep our current action APIs because they're convenient, we'll wrap that logic for you. But generally speaking, using these like generic low-level tools, is errors are not tied to optimistic updates or pending state. You manage them right now. Obviously, this doesn't work great with progressive enhancement. So like to make it work, there will be wrappers around it, like the use submission from the router and stuff, to like have the like these seamless things. Like I picture our APIs in the router here actually staying basically the same, but it's cool to have them built on a more baseline primitive that works in the more general case and is much more powerful. Patterns for async data. What do I got here? Yeah, I was started kind of wondering. Yeah, as I started working through this, I realized that because I've showed this before, but solid 2.0, when you pass a function to signals, they become derived signals. Basically, they become memos that are writable. And similarly, if you have a store and you pass a function to it, they become derived store, which makes them a projection that is writable. And I started noticing as I was playing around with these that without transitions, like just on the base case, you might do this a lot. You might fetch some async data and then turn into a store, basically, by diffing it. This is what the reconcile function does. And then whenever the async data updates from the server, you diff it, and otherwise you can just mutate it like a normal store. I can see tons of people using this pattern for doing like fine-grained store updates on async data, right? And in the sense, if you put these together, this is create async store, right? It's not too hard to see how these compose. The diffs the data wherever it comes to the server, but then you're free to override it as much as you want. It's basically the granular equivalent to a derived signal. This technically has optimism built in because you're setting the store and then you fetch manually. But when and how you say the data is up to you. It is very client-centric thinking. Conversely, with transitions, you might do this. You might go create async fetch data, right? And then create optimistic, store mutate, and then use those things to like I've shown before. You've seen this before. It's a reducer, right? The difference here is the lifetime and the ephemeral state is set by the transition that uses the mutate function. Basically, you can't update the store without also scheduling a transition that refreshes the data. It's a much more constrained pattern, but it automates a lot of the pieces. Both approaches use projections under the hood, but the latter is more guided approach, right? This is kind of like the you can do anything with solid approach, and this is like the happy path, like use the features properly approach. Okay. Should all projections look like this? I was tempted, and I went through this kind of side where I was like, what if projection API always looked like this, where you had like a baseline that you could derive from, and then you could like do this, because it kind of makes sense, you know? But what I realized is for this API to work, you have to be able to do the diff at the end and know how that diff works, which means that if you want to be performant and actually diff against the projected data and not like lose things in the intermediate steps, you have to wait till everything related to this projection is like all the futuristic stuff, like all the optimistic stuff is basically resolved, so that you can get rid of it and rebase it when the base happens, which actually turns out difficult to do manually. Transitions manage this for us, or can manage this for us, because transitions have a set guaranteed finish time, and you can go look until these things are entangled, until the transition's done, we can't, clean this up. So you could be running multiple transitions kind of and getting entangled in multiple actions as you go, and be living in optimistic state for a while until you finally stop typing, and then optimism, clears out and you're done. But basically, as long as the final diff happens when all this, you're sure that the server has all the stuff, then you're fine. But in the general case of projections, you wouldn't know that, which makes this not a suitable API for projections in general. That's the short version of this long write-up. Yeah, the fact that it makes the win here is the Strello demo literally turns into this, which is just beautiful, because as I said, it's finally as easy, if not easier to write than like the React version of the code, and it's way more performant. So because it does fine grain all throughout. So I'm pretty stoked on that. But I haven't implemented this yet. This is the design thinking here. Yeah, use action state driving people crazy. We're going to get to in a second here, because I'm talking about the API design. I think actions are where we go to next. Let's talk about actions. I've done this one, What do I have left here? Let me just look at topics. Single feature we already talked about. Okay, actually, this is related. Yeah, what's my last hack MD? I just want to see if it's relevant to anything. Is create optimistic the right API? Okay. I might not get to this one today. We'll see. This is you have to understand stuff on the other side before we get to this one. So let's continue with let's actually go. Yeah, now's a good time to go address all the Twitter stuff related. Yeah, because I'm trying to remember where the best conversation for this happened. I think it actually happened on Blue Sky. It's hard when you have everything in multiple places. Oh, I forgot to say I was live. Oh well. Okay, cool. So let's look at this video and see what's happening. Okay, start at the beginning. We have 5 buttons on the screen, okay? Right? And clicking each one at a time, okay? And you see these fetching sequentially. I'm actually not sure if it's not just his clicking that's causing them to go sequential here. But the more important part is these 2 are finished already, but these still say acting on them. In fact, these 3 are finished and still saying acting. Let's keep going a little further. All of them are finished except for the last one, still saying acting here. And then finally, done. The answer is because there's a single future in transitions. These are all kind of seen as they all get entangled, right? So there's a comment here on this post that says, "Is there no way to use server functions in React without their pending states all being tied together?" Which is fair. And the answer is no. Basically, if you want to use transitions, you can use server functions without transitions. But if you're using transitions, then the answer is no. So yeah, this gets where the confusion starts. Ricky goes, yes, they're parallel by default in React. You may be using use action state in which you're opting as serial processing or doing the pending state and async transition, and all transitions are entangled together. Until we build parallel transitions. Okay, so one of the things is use action state. Like their form processing version actually forces them in order. But this one you can see it's not in order because it fetches, like it's fetching 3, 4 at the same time. If this was use action state, it would do the first one, finish, do the second one, finish, do the third one, finish, do the fourth one, finish, do the sixth one, which is not great. You know, there was a whole controversy about this because that's like the default behavior, and no one was expecting that from Next. I, however, in my retweet here, actually defended the React and Next position on this stuff, and I want to explain a little bit why. Not the use action state thing. I don't think almost anyone wants serial behavior like that. But this isn't serial behavior. This is just all the pending states being entangled. In fact, which means that it won't update the UI until the last thing comes back. And there's a very, very good reason for that, right? And I think we're going to have to do some Excalibur to talk about this in a second. Yeah, that's all I want to know. Use action data, you opt in serial processing, where else transfer globally tied together. I disagree with your take on APIs. Of course, this is artificial, though. How? So I test the worst case. You're probably right. I do want to use optimistic updates here. In general, I probably won't suggest using action, use action data, how they behave. Also want to have rules without escape hatches. Plenty of websites have good Wi-Fi or clicking around and having plenty of states all tied together. Single would not be a pleasant experience. Actually good and convinced data. I'm sorry, I don't use extra forces. Blah, 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 blah. I think features that use actions for this barrier, it's opt-in when you exactly option not use action, you raw actions and start transition, which run in parallel. Then you need to handle race conditions and out of order states yourself. saying that use action is required to use action, but it's not. You can change your thing. But the thing is, these are in parallel, and you're still getting this behavior, which is why I want to flag this out. Okay. So let's talk about this. Why do I think? Because I sit here, I need to remember to talk about this in the next stream. What React is doing is quite logical here. I see a lot of parallels between actions and use effect. They break the dependency graph so you can no longer automatically be smart about what they impact. Even with better async primitives like we have solid, our graph is on the get side. It's derived. We can trace the state change to it appear in the UI. Set user ID, get user with ID, do this. I showed this a moment ago when I was showing Dev's demo, how we could like basically trace through this stuff to do suspense, error boundaries, even transitions. But actions don't tell us their downstream dependencies. Like use effect don't tell you what state to write to. This is basically the async version of the same shape of problem. Anyways, food for thought. What I'm trying to say is, and to be fair, the live view guy was nailing Remix about their optimistic updates, saying that it wasn't safe. And it's a very similar conversation here for why we have to use transitions this way. Because a lot of people see this kind of behavior and like, oh, this sucks, I'm not going to use it. And then they actually introduce a bunch of race conditions and they try and solve them, but then they miss a few cases, generally speaking. The problem is that it takes specific knowledge to know that you can't merge these together. Because as I said, it's not too hard for us conceptually to use the reactive graph to know when we can merge different transitions on the get side. But on the action side, we don't know what the server is going to be like. Oh yeah, invalidate this data now that you've done this action. We don't know that. And the problem is this. Okay, let's draw this out. Let's look at some kind of. I'm trying to think of how to best show this timeline. So let's use solid lines and let's do some kind of fill in background color. So start with red maybe. Let's fill. Okay. Because I'm trying to think of like how to show this in terms of timing, because there's basically the first step is let's do medium. Initiate action on the client, okay? Like, let's do this. Right, and then of course. And then the next state here is apply mutation on server. Let's give it a blue. Okay. And then I mean, it's actually, I haven't drawn this one before, so I have to actually think about this a bit, about where we want to yeah, I think I'm going to need more steps than this. I wanted to do it like this instead of a timeline though, because let's see if I can get it here. Initiate fetch on client. And then finally get data from DB server. And then, sorry, I just got one more stage, which is update UI and client. I mean, it's a little bit simplified. I'm probably going to need more steps here, I think. Do I have enough of these? Colors? Probably not. That's fine. I'll use these. You can this has mostly to do with optimistic updates. So if Next doesn't have optimistic updates, or Next, sorry, then you might not see this, but this can always happen actually. I think this has, I mean, a lot of solutions don't solve a lot of these edge cases for you anyways, which is why sometimes like when Jose was going off on like the LiveView guy on this stuff, I was kind of like, yeah, and so has every client-side application for all of eternity. So like, you just have to manage this stuff, you know. But I want to show that there's this sequence, right? And the challenge is these things can happen. I'm going to shrink it down a little bit. These things can happen with different timing, right? Now, it's not until we get to here that we know with an action like what the downstream impact is. This is when we like this part up here, like get is here. And I'm not gonna include single flight mutations for a second here, but it's the same kind of conceptually thing. Like I'm only keeping this for a second, but I just want to point out that there's two parts of the cycle. There's the post and then there's the get. Right? There's the mutation and then there's the like, you know, revalidation or whatever. Like it's true that this could just return the data with it immediately and then, you know, but the problem is like the impact of this could be more than just the scope of what launched it in the first place. This is why we have stuff like TanStack query, why, you know, we have loaders at Remix working at a fairly global scale at the route level. Like there is this part of the cycle, you know, React server functions that they include their server actions, I guess are now server functions too, basically do this and then return server components, which is kind of like the get. Like there's this full cycle, right? You post to a page and you get the next HTML, right? This is common. The thing is, if you have multiple of these things going at the same time, okay, right? So let's grab another one of these. And let's just offset them a little bit, right? This is the simplest case, right? In the simplest case, as I mentioned, it's only on the get that you understand that they are actually entangled. So if we just don't do anything special and assume that transitions are not entangled until they hit a reactive graph node change, the simple case is actually fairly helpful here, because the simple case, when you're doing the fetch on the client, you set the state. This is when the transition classic starts. And this CellSolid 1.0 actually works with its stuff. I didn't actually wrap the action part in the transition. There's a reason I want to in 2.0, but initially I just did it here. So what would happen is when this gets to here, it realizes that it's the same transition. It's impacting the same data set, right? If these would be entangled, right? We only care about the entangled case. In the not entangled case, then yeah, these things can go independently. We don't really care, right? But it's when we get to like set we go, yes, we succeeded, refresh the data with this ID. At this point, we have our more synchronous, like we have the full reactive graph in this get side. And when this hits it, it can see that it overlaps with this because it's happening at the same time. And what's beautiful about this is it knows this one happened after, right? So it actually will cancel out this one, so to speak, right? Because of like create async essentially knows that like it handles these kind of race conditions, which is great because, if something weird happens here, like you're doing this one and it suddenly, for some reason does this. Sorry. If this happens, you know what I mean? It's gonna go. It's basically gonna ignore this, and it's just gonna continue on from here. Like this part just won't exist. It'll just be like bye bye, right? But so you get some protection automatically simply by the fact that because these get locked in a transition sequence, that and the because of the it actually technically because of transition will wait for them both to come back, I guess, which is arguably but actually if they're the exact same data being fetched, it will be canceled if it's the exact same like data source being updated because of the internals of create async. It'll just like basically cancel the first one, right? Okay, but basically this already is kind of helpful. The challenge is what happens if so most of the fetch side stuff gets handled automatically now because of transitions and async primitives. But what happens if these two miss each other? Like if I move this just a slight bit further to here. Now, oh, actually, this isn't quite right. I can move it a little bit further. We gotta move this to here so after this gets back, right? Because this can happen in solid today. The transition ends before this green part happens. So when this goes to go, it doesn't actually see that it overlapped if we didn't start the transition here. So, and it's possible, depending on when this apply server mutation on the server and this get data from the database happens, for this apply to happen before this get. Do you see what I'm saying? So this to actually get the change from this action ahead of time before it actually like should, right? And as I said, in a basic case, no one actually notices this in general. Okay, I can zoom in a little bit more, but I'm pretty wide here. Let me see if I can move myself down. Maybe this is better. What I'm trying to get at is it's possible for it to save on the server before the get cycle happens, and for this to update the UI with both changes, and then go to update again with both changes. I mean, this is not a big deal for normal UI, but this is actually a really awkward for optimistic updates because because the timing of this fetch happens after the transition ends, it doesn't make them the same transition. If you only start the transition on the get side and not on the action side, which means that like if this optimistic update was to add one item, and then this was to add another item, right? So you've now got 2 items sitting there. Well, like extra items on the end of the list. When this finishes, it goes, okay, I'm done my transition, and they didn't get interlocked. They didn't realize they were the same transition. So it removes the one item that it was intending to. The other item stays there, but it returns the data for both items. So briefly, between this rendering and this rendering, the second item is going to appear in the list twice. Once as new and once already there, right? Because it returned it because it already applied the mutation, right? Because these did not get interlocked. Like they didn't entangle because the transition started too late. Similar things with deletion, where like if one needs a deletion, you'll see stuff delete and then show up again and then delete again. These kind of things can happen with optimistic updates if essentially these aren't tied together as the same transition, but they don't know they're the same transition because the transition ends before this one actually figures out its data dependencies. This is kind of the challenge. The funny thing is, as I said, without optimistic updates, you wouldn't probably notice this because, I mean, we're all kind of accustomed to this kind of behavior. Like you're on a website and a different user updates the state, not you, but like a different user updates the state. And when you do a save, not just your new data, but like other data comes in too. It's a little bit jarring, but you're like, oh, someone else must be on this page, right? Yeah, I don't have time to make these kind of demos per se. But yes, I mean, these are just conceptual. Like, I think Jose from LiveView on Twitter, I maybe dig it out a while ago, did a decent job of like picking apart a website that had these sort of issues. You've probably seen them before and not realized the cause of them. But yes, this timing bit is a little bit awkward. The ways to fix it, right, is if you entangle this, then you know not to update you know not to do the update until the end here. Solved. But you don't know the entanglement. I also just realized the solid events creates a graph for the post side. It can tell us everything that will be updated right at the beginning of the event. That's interesting, right? Because one of the API choices is basically to tell the transition like this is what will update, but it might not know because the server might fail or work a certain way, and like you can dynamically choose what gets invalidated at mutation time, right? So like it's the other solution to this though that I was thinking about is if you're okay with this happening when optimistic updates aren't involved, we could just entangle. Like you have 2 options. You basically have to say, look, all actions, when there's actions involved, have to entangle, right? You can go like, you can do the get stuff as much as you want, but as soon as you have actions, they're going to entangle, which means you're basically back at this React example. It's not unreasonable. If they didn't do this, stuff like I'm showing you right now in the Excalibur draw can definitely happen, especially, and these are not the kinds of things like, as I said, people are accepting when optimistic updates aren't involved, but as soon as optimistic updates are involved, this is not the developer's fault for not handling these edge cases. This is the framework's fault. Like React knows that. If they didn't say this was the behavior, like, and you had your optimistic updates popping in and out, like they can't offer an optimistic primitive and not handle this case, right? So like it makes perfect sense for it to work the way that it does. I'm not action state, that's a whole other thing, but for transitions in general to work like this, that they encapsulate they don't know what's going to happen and they encapsulate the action state. But yeah, I mean, what I'm thinking is interesting is if these are related to the same data and they feed through the same optimistic updates, that could be the indicator that they entangle, right? Because without optimistic updates, you might not actually care if this happens. Do you know what I mean? So that's my working principle, at least right now. We'll see how this goes. But there's a whole bunch of situations you get when these timings compress